In the previous lesson, we understood the need for SysML compared to UML modeling language. Although SysML is in constant evolution at OMG, since version 1.4 is there, this version will certainly not be the solution for everything. Modeling and checking non-functional properties like security and safety will certainly require more adaptations or other complementary models and tools. Yet, using a model-based approach supported by one or another toolset is essential in modern embedded system engineering. SysML is based on 4 pillars: structure, behavior, requirements, and parametrics modeling. We will now give an overview of these pillars and show how important the mutual relations are. Structuring can be done using the package diagram, block definition diagram, and internal block diagram. The package diagram, also found in UML, is a namespace that may contain any model elements, including other packages. A package diagram contains information about the structure of a system model or about a package containment hierarchy. There are 4 types of packages. This diagram is often used to convey the logical groupings of model elements and to help stakeholders navigate the model structure. It is good to know that each type of diagram has an abbreviation, which is always displayed in the title of the diagram. Package diagrams are labeled PKG. Here you see a couple of examples of PKG diagrams, ranging from a simple one like this to a more complex setup like this one. Being able to tell the differences between packages and block diagrams is a matter of experience. The block definition diagram labeled BDD is a modified version of what can be found in UML. It defines the features of a block and any relation between blocks. It is the primary kind of diagram one creates to communicate structured information about the system. It enables one to identify the types of structures that can exist within a system and in the environment of a system. BDD can also be used to name the types of services each structure provides and requires, the types of constraints each structure must accept, and the types of values that can exist within an operational system. This finally means that blocks can be almost anything. Examples are a system hierarchy, a system classification tree, system of systems blocks, and a hardware block structure. Details of one level down or an inner element can be defined with the internal block diagram, labeled IBD. It captures the internal structure of a block in terms of properties and connections among properties. A second aspect of SysML is the possibility to describe system behavior through the use of use case diagrams, activity diagrams, sequence diagrams, and state machine diagrams. Use case diagrams are known from UML. They are labeled UC. They let you display various kinds of elements and relations to express information about the services the system as a black box provides and about the stakeholders or users requiring these services. A use case represents a declaration of an offered behavior. The actors represent external human users, hardware, and other subjects. Modelers often use these diagrams to serve a system context diagram, offering an overall view of the system in an early stage of the life cycle. Activity diagrams or interaction diagrams, being modified versions of UML, expressing systems' dynamic behavior, are labeled ACT. They too represent an overview and details of flow of matter, energy, and data in interactions that are also defined in sequence diagrams. Activity diagrams are graphical representations of the workflow of stepwise activities and actions, with support for choice, iteration, and concurrency. They are intended to model both computational and organizational processes or workflows. Sequence diagrams are inherited from UML and also express the dynamic behavior of systems in addition to an activity diagram. This is a very classical model already used in early modeling. It describes the interaction sequence or communication between different model elements. The diagram shows vertical lines which may represent different types of model elements. The participants to the action called lifelines. The horizontal arrows show interactions between the participants and at the same time show the order of these transitions. A system sequence diagram can be used for detailing the behavior in the context of a use case, but it can also be used to define a network protocol or any other dynamic behavior. It depends on what the lifelines represent. State machine diagrams is a very classical and old construct that explains the different finite states and state transitions for a particular model element. Different kinds of transition triggers can be defined. Of course, not all structures have a defined set of states, but if they do, then this diagram is the diagram that will help you out. It enables efficient communication within the team and towards the stakeholders and users. The requirements are modeled by a requirements diagram, which is totally new to SysML. It provides modeling constructs that help represent text-based requirements and relates them to other modeling elements of any kind. They are intended to provide a bridge between traditional requirements management tools and other SysML models. These diagrams display requirements, packages, other classifiers, test cases, rationales, and relationships. Parametrics are achieved by a parametrics diagram, unique to SysML. It delivers information about systems constraints, which are in most cases mathematical constructs or models determining the set of valid states within a running integration of engineering analysis, such as performance and reliability models or other SysML models. Not all designs need this very special construct. It enables the communication of these aspects to the stakeholders, but can also be considered the basic information needed in the generation of test cases and automatic code generation. This overview of different diagrams shows the modeling capability of SysML for embedded systems, both devices and a large system of systems. Using these diagrams and tools requires experience. This means practice, practice, and more practice. Now it is time to give it a try yourself. Good luck.